So hello everybody, my name is Paul Lofey. I will introduce you to Hypertrace project. And Hypertrace is an open source API observability and distributed tracing platform. It has been open sourced last year by a company called Traceable. And in this session, I will divide it into two parts. First of all, I would like to talk about distributed systems in general and kind of go through why these systems are very complex and why we should care about observability. And then in the second part, I will talk about Hypertrace as a project in general, and I will show you, what kind of capabilities it provides, and I will show you, how it looks like to use it. So just briefly about myself, as I mentioned, I'm software engineer at Traceable. On daily basis, I contribute to data collection in the Hypertrace project. By data collection, I mean that I work on instrumentation libraries that collect data from your application runtimes that is then sent to the platform. Before joining Traceable, I was, and I'm still, core contributor and maintainer of Cloud Native Computing Foundation projects, Jaeger, Open Tracing, and I also contribute to Open Telemetry. And if you would like to reach out to me, there is my Twitter handle, plofey. So understanding deep systems. By deep system, I mean any distributed system. Basically, most used term is a microservice architecture. And why, why deep systems? So the kind of not issue, but the way how we write our current modern applications is that we write distributed systems. These applications are split into multiple modules, into multiple processes that run on different hosts. And so by definition, distributed system can fail because there are so many parts that can change. And basically now, when you load any modern mobile application or web application, what happens is that when a request is sent somewhere to cloud, the processing, happens on multiple machines. So when the response is written to the user, usually the processing of the request went through maybe dozens, maybe hundreds of services. So it's very complex processing. It's not longer a single, system that replies to us with a response. The processing is much more complicated. So on this screen, we see an architecture from Uber, and it's basically a screenshot from Jaeger system, and each dot represents a single service. And so, for example, when we are ordering a ride, the request from our mobile application goes somewhere to cloud, it hits the load balancer, and then it reaches the first service, and then the first service talks to another service, and this continues like this until the full response is returned to the user. And as you can see, the processing can be, quite complex. There may be dozens of services that, talk to different databases, talk to different messaging systems until we have the full response for the users. And so when speaking about complex systems, on this slide, we see Amazon.com and Netflix. And as you can see, there are so many microservices or so many nodes that it's we are not able longer to understand the system by just looking at it. So how do we monitor these systems? We basically, traditionally, we used to use metrics and logs to understand our systems. And don't get me wrong, it's a still valid telemetry that we should be collecting from our applications. So let's talk about metrics. Metrics are great. They provide immediate kind of knowledge or some value from the environment. We see that something, is happening. We see whether memory is increasing, or we see that, the error counts increasing. But by looking at the metrics, we see only that something is happening. We cannot answer the question, what is happening? And more importantly, why it is happening. So there is no context in metrics. On the other hand, in logs, there is so much context. When we see logs, there is a lot of information, a lot of log messages, but there are two fundamental problems with logs. First of all, there is too much data, and nowadays each service it serves multiple concurrent requests at the same time. So these logs are kind of mixed together for different transactions. So if we want to understand logs, we have to correlate them together, to correlate the logs for a single request to be able to understand them. And then when we are talking about distributed systems, we have to correlate logs across different systems, which is even more complicated. The second problem with logs is that there is no data standardization. So each application runtime emits different logs. So let's say in Spring Boot, for request processing, the Spring Boot log different data than, for example, a Golang application. So in a really polyglot environment, it's very hard to understand because there is no standardization for the log messages. So how should we solve this problem? In my opinion, the answer might be distributed tracing. And nowadays in the industry, we call distributed tracing as a third pillar of observability, as a new signal that we are able to collect. But when you think about it, it's nothing else, just contextualized logging. So you can think about it like logging message that has a unique ID for the transaction or for the request that goes through multiple systems. And then there is also causality. So you know what operation happened because of which operation, right? The other way of thinking about distributed tracing is something like distributed stack traces. I'm pretty sure that you can imagine a stack trace from, for example, Java, but think about it like I would get a stack trace that also has all the upstream services, that are now in the invocation. So distributed tracing basically shows you end-to-end invocation, and so I think it's a great way how we can understand end-to-end what happens with the request or with the transaction to truly be able to pinpoint issue in the distributed systems. So this brings us to Hypertrace, because Hypertrace is an open source API observability and distributed tracing platform. It brings a lot of great innovation to the open source tools. I have been a long time working with Jaeger and Zipkin, and these tools are great. They provide a lot of value, but there is still missing some functionality in terms of overall dashboarding and concepts around APIs and metrics. So Hypertrace, it's not only observability platform, it's end-to-end solution, which means it also provides libraries, which are usually agents that collect data or instrument your application to collect data for the platform. So right now there is Java agent, Golang agent, and more will come very soon. However, the Hypertrace uses OpenTelemetry collector, which is basically it's an open source component that is able to ingest data from many open source libraries. So if you are already using something like Zipkin, Jaeger, OpenCensus, you can just change the configuration and redirect that stream of data to Hypertrace. Hypertrace is meant to be used by developers, application teams, SREs, or deployment teams. So for example, as the Hypertrace has a concept of service, as we will see in a minute, it's able to compare the performance against multiple versions of the same service. So let's have a look at other capabilities of the platform. So Hypertrace can show you the topology diagram or the architecture diagram. And this architecture diagram is constructed by observing the invocation between services in your environment. So it's always up to date. It doesn't have to be changed by user. Then there is dashboarding. We will see that in a minute. And the platform, as it is open source, it's very easy to extend. It uses GraphQL API and Trace Analytics. So there's Apache Pinot and Kafka streams. And so, for example, if something is not there in the platform, it should be fairly simple to extend it for the specific use case or your business need. And as I mentioned, Hypertrace is it integrates well with other distributed tracing ecosystems. So if you are already using something, most likely you can keep using that and just deploy Hypertrace and see the data in this platform. So let's have a look at the UI. So now we'll follow a couple of screenshots. So this is the main screen in the platform, which is called dashboards. It shows you the overall state of the application that you are monitoring. So you see the data like latency, number of calls, number of errors, and also the most important endpoints, which are at the bottom. Then on the left, there is a menu, and we will go to the second screen, which is application flow. And in the application flow, we see the real-time architecture view. So let's say here we see a bunch of microservices and connected to each other. So we see this line only if this service is calling with is talking to this service. And each line also has some metadata that show you the average latency time, average number of errors, and so on. Then more important parts is the endpoints. So Hypertrace automatically detects endpoints from the applications and the services that you are monitoring. And for these endpoints, we calculate high-level statistics or metrics like P99 latency, again, errors and number of calls. Then there is concept of a service. And a service is very similar to the dashboard, but these metrics in the service view are scoped to a single service. So again, we have latency, number of calls, errors, but also the fraction of the architecture diagram. So now we see that our service, which is streaming sessionizer, talks to the trace enricher. The trace enricher is the upstream service that calls the sessionizer, and then the sessionizer calls another set of services. From the service screen, there is also, we can go to endpoints where we see the endpoints for service, the traces that are linked to this service, and also the metrics. So as other distributed tracing tool, Hypertrace can also show you this very detailed view that is, some kind of Gantt chart. That this screen is great to understand end-to-end transaction. It has a lot of details. And then there is the metric view for a specific service. And last but not least, Hypertrace, as I mentioned, is open source project, so you can go and start using it today. You can find us on github.com/Hypertrace. We have also hypertrace.org website where where all the links that you can follow. We have also a Slack channel where you can talk to us about anything related to observability. We can help you to get started with Hypertrace, but also help you to for example, instrument your ecosystem or give you some advice on observability in general. So thank you very much, and don't forget to follow us on Twitter at hypertrace.org. And if you have any questions, feel free to reach out to us, and we are excited to see you in the Hypertrace community. Ketesa, thank you very much.